Good students, now consider the third method for the solving of the linear equation systems. This method is named the inverse matrix method. At first write the general form of the third order linear equation system a11x plus a12y plus a13z equals b1, a21x plus a22y plus a23z equals b2, a31x plus a32y plus a33z equals b3. Here a sub ij are the coefficients of the given system, and b1, b2, b3 are the constant terms. Here the following matrices will be used. The matrix of coefficients. Matrix of coefficients a11, a12, a13. This matrix consists of only the coefficients a21, a22, a23, a31, a33, a32, a32, a33. The column of constant terms B capital denoted B capital, B1, B2, B3, and the column of unknowns X capital equals X, Y, Z. For the solving of linear equation system by the inverse matrix method, we can represent the general form of third order linear system in the matrix form. That is, we must write the linear matrix equation. For this, calculate the expression a multiplied by x. Here it is matrix A, right? Matrix A, A11, A12, A13, A21, A22, A23, A31, A32, A33, multiplied by x, y, z. X, y, z. Remember the multiplication rule of matrices. The dimensions of the left matrix is 3 by 3, and the dimensions of the right matrix are 3 by 1. Here, according to the multiplication rule, we must delete the middle equal dimensions, and the rest of dimensions will be the dimension of the product. Then continue. Equals here we must obtain the matrix with dimensions 3 by 1. At first write the general form of this matrix of product matrix C11, C21, C31. For obtaining of the first element C11, we must multiply the first row of the left matrix by the first and unique column of the right matrix. and this multiplication is realized by the rule of scalar product. It means A11 multiplied by x plus A12 multiplied by y plus A13 multiplied by z. Then for obtaining this element, we must multiply the second row of the left matrix by the first column and also the unique column of the right matrix. A21 multiplied by x plus A sub 2 multiplied by y plus A23 multiplied by z. And finally, for obtaining the last element C31, we must multiply the third row of the left matrix by the first column of the right matrix. A31 x plus A32 y plus A33 z equals. Then we have, according to the general form of the given linear system, the first row is B1, the second row is B2, and the third row is B3. Right, B1, B2, B3, and it is the matrix B capital, that is the matrix of the constant terms. And from here we obtain the matrix, linear matrix equation. A capital multiplied by x capital is B capital. It is the linear matrix equation. The linear matrix equation. Then multiply the obtained linear matrix equation from the left by the inverse matrix A super minus 1. Multiply A super minus 1 multiplied by A multiplied by x equals A super minus 1 multiplied by B. You know that the A super minus 1 multiplied by A capital is a unit matrix. I capital multiplied by x is A super minus 1 multiplied by B capital. But also it is known that the product of the given matrix by the unit matrix from the left or from the right will give the given matrix itself. And we have x capital is A super minus 1 multiplied by B. It is a formula of solution of the linear matrix equation. Then use this formula for the solving of linear equation system by the inverse matrix method. Now apply the inverse matrix method for the concrete linear system. We have the given linear system and solve the linear system by the inverse matrix method. First, rewrite the given system in the standard form. System 0 multiplied by x minus 3y plus 4z equals minus 7. Minus 2x plus 3y plus 0z equals 7. 3x plus 0y plus 2z equals minus 8. Here in the first equation 0 multiplied by x, because in the standard form, the term with unknown x is absent, and here 0 multiplied by z, because in the second equation the term with z unknown is absent, and in the last equation we have 0 multiplied by y, because in the third equation there are not the term with y unknown. At first, form the coefficients matrix A capital. A capital equals 0, minus 3, 4, minus 2, 3, 0, 3, 0, 2. For obtaining the inverse matrix, first we must find the value of the corresponding determinant. Delta equals determinant A equals determinant 0, minus 3, 4, minus 2, 3, 0, 3, 0, 2 equals you can use any method of calculation of the third order determinant. Usually I use the triangle method. 0 plus 0 plus 0 minus 36 minus 0 minus 12 equals minus 48 isn't equal to 0, and it means that the inverse matrix exists. Now find the inverse matrix itself. A super minus 1 equals 1 over determinant of A multiplied by matrix plus M11. Already you know this formula, minus M21 plus M31 minus M12 plus M22 minus M32 plus M13 minus M23 plus M33 equals continue. We keep the constant terms. Continue. 1 over minus 48 multiplied by plus M11. Here we must delete the first row and first column, and then we obtain the following minor 3, 0, 0, 2 minus M21 1 minus 3, 4 minus 3, 4 3, 4 2, 1 and 0, 2 plus M31 3, 1 minus 3, 4 minus 3, 4 3, 0. Here note the column of the constant terms. B is minus 7, 7, 8. Then continue minus M12 1, 2 minus 2, 0, 2, 0 1, 2 1, 2 3, 2 3, 2 plus M22 0, 4 0, 4 3, 2 minus M32 3, 2 0, 4 0, 4 3, 2, 3, 2, minus 2, 0, minus 2, 0. Then plus m1, 3, 1, 3, minus 2, 3, 3, 0, minus m2, 3, 2, 3, 2, 3, 0, minus 3, 3, 0. And finally write plus m3, 3, 0, minus 3, 0, minus 3, and minus 2, 3, minus 2, 3, equals, continue, continue. Continue, equals minus 1 over 44, I'm sorry, 48, 6, minus 6, 6, then minus 12, minus 12, 4, minus 12, minus 8, minus 8, then minus 9, minus 9, minus 9, and minus 6, minus 6. It is the inverse matrix, inverse matrix. Then write the components of unknown x, the column of unknowns. X capital equals a super minus 1 multiplied by b equals minus 1 over 44 multiplied by matrix 6, 6 minus 12, 4 minus 12 minus 8 minus 9 minus 9 minus 6, and multiply by minus 7, 7 minus 8, minus 7, 7 minus 8. Here the dimensions of the left matrix are 3 by 3. The dimensions of the right matrix are 3 by 1. Here we will delete the middle dimensions, middle equal dimensions, and the rest of dimensions will be the dimensions of the product matrix. Minus 1 over 48 multiplied by 6 by minus 7, minus 42 plus 42 plus 96, then minus 28 minus 84 and plus 64, then 63 minus 63 and plus 84 equals minus 1 over 48 multiplied by 96, here minus 48 and 48, and you know that the multiplication of the given matrix by the constant number, all elements of this matrix is multiplied by this number, equals minus 2, 1, minus 1. It is answer. They are the components of the solution, and we can write answer x, y, z equals minus 2, 1, minus 2, 1, minus 2, 1, minus 1. 1 minus 1. It is answer. Now rewrite the homework, solve the given linear systems by the inverse matrix method. Then consider the next method for the solving of linear equation systems, named the Gauss method. The Gauss method is similar to the echelon method for the finding of the matrix rank. Again, write the general form of the third order linear system. A11x plus A12y plus A13z equals B1. A21x plus A22y plus A33z equals B2. A31x plus A32y plus A33z is B3. Here the following matrices will be used. The augmented matrix, that is genişlendirilmiş matris, расширенная матрица, augmented matrix, denoted A with line, here the coefficients are written, and also the constant terms are written. A11, A12, A13, B1, A21, A22, A32, A32, B2, A31, A32, A33, B3. We can separate coefficients and constant terms. At first, mark the main diagonal. It is main diagonal, and we must transform all elements under the main diagonal into zeros. And after transformation of triangular matrix, we must return to the corresponding linear system. Then consider the application of Gauss method to the concrete linear system. Now consider the example about the application of Gauss method to the solving of the linear equations system. Review the given system. At first, form the augmented matrix. 3 minus 2, 4 minus 12, 4, 3, 2 minus 7, minus 2, 4, 3, 5. And separate the constant terms and mark the main diagonal. First, we can transform the element 4 into 0. For this, multiply the third row by 2 and add it to the second row. Multiplied by 2 and add it to the second row. Equivalent. It is equivalent. Here only the second row will be changed. 3 minus 2, 4, minus 12, 0, 0, 8, 11, 11, 11, 8, 8 and 3. 11, 8, 3. Yes. Minus 2, 4, 3, 5. Here, of course, here the matrix is changed, but its rank is not changed, and it means the solution of the given system is kept. Then again mark the main diagonal and transform the element minus 2 into 0. For this, multiply the first row multiplied by 2, and third row multiplied by 3, and then change the first row, add to the changed first row, changed add to the changed third row. Multiply by 2, multiply by 3, and add the first row to the third row. Equivalent. Here only the third row will be changed. 3 minus 2, 4, minus 12. 0, 11, 8, 3, 0, 12, minus 4 is 8, 17, and here 15 minus 24 is minus 9. Then again mark the main diagonal and transform the last element 8 into 0. Here we can use only the second row. Multiply the second row by 8, and third row by minus 11, and add the changed second row to the changed third row. Then continue. Then continue. Here only the third row will be changed. 3 minus 2, 4, minus 12, then 0, 11, 8, 3, 0, 0. Then we must find the value 64 minus 187. Minus 123 minus 123, then 99 plus 24 is 123. Already we have the triangular form of the given matrix, and then we can return to the corresponding linear system. 3x minus 2y plus 4z equals minus 12. 11y plus 8z equals 3. and minus 123z equals 123. We can at first find the value of z unknown from the third equation. Z equals minus 1. Then substitute minus 1 instead of z in the second equation. Then we can find the value of y equation, y unknown. 11y plus minus 8 equals 3. 11y equals 11 and y is 1. And finally substitute the values of y and z 1 and minus 1 instead of y and z in the first equation. And then finally we can find the value of x unknown. 3x minus 2 multiplied by 1 plus 4 multiplied by minus 1 equals minus 12. 3x minus 2 minus 4 equals minus 12. 3x equals minus 6, x is minus 2. Already we obtain the value of x unknown, and therefore we can write the answer. xyz equals minus 2, 1, minus 1. It is our answer. Finally, please rewrite your homework. Solve the linear equation system by the Gauss method. And please rewrite my email, and if you have your questions to me, then you can send your questions to my email, mserifli@beu.edu.az. Thank you very much for your attention.